say we're looking at adding 3/4 and 7/8. Okay, so if I'm adding 3/4 and 7/8, again, to be able to add fractions, we must have the same denominator, or in this case, the same bottom number for both fractions. And for 4 and 8, if we take the least common denominator, and that's going to be the smallest number that both 4 and 8 will go into, and of course that is going to be 8 itself. So 7/8 is already in terms of the least common denominator. But with 3/4, I have to make an adjustment. Okay, so we have with 3/4, I'm going to go from 3/4 to its equivalent in 8ths. And what I'm going to do here, so I'm going to rewrite 3/4, and what I'm going to do here, I'm going to take 3/4 and multiply by 1 in the form of the number that 4 will go into 8 divided by itself. So to go from 4ths to 8ths, I'm looking right now, so I'm raising from 4 to 8, so 4 will go into 8 2 times. I'm going to do the same thing in the numerator. So I'm multiplying by 1 in the form of 2 halves. And since 7/8 already has the least common denominator, this will stay as it is. So for 3/4, we got 3 times 2 is 6, 4 times 2 is 8. So 3/4 is 6/8, and we have plus 7/8, and we have here the same denominator, and adding the numerators. So we have 6 plus 7 is 13. So we have for this output, okay, we have at 13/8. Now let's say that if I have variables involved, and we'll say that we have here 5 over 2x squared y, and 3 over 4x y squared. Now if I'm looking for the least common denominator, again, I'm not looking at the highest term that will go into both 2x squared y and 4x y squared. I'm looking at the smallest term that both 2x squared y and 4x y squared will go into. So between 2 and 4, smallest number that both of these will go into will be 4. And in terms of the letter x, that which will satisfy both x and x squared is x squared. And in y, for y and y squared, and y squared. So to be able to add these fractions, you need to have these in terms of a common denominator. And the least common denominator, we have a 4x squared y squared so taking what we have in the sum and re-expressing the ratios. Okay, so I have 5 over 2x squared y. Okay, so looking at 2x squared y with respect to the least common denominator. So 2 will go into 4 2 times. You already have x squared into itself is 1. Then we have y into y squared, still leaves a degree in y. As for 3 over 4xy squared, okay, so we got 4 going to itself once, x into x squared goes x times, and guess what, we already have y squared from this second denominator, so I had to multiply by 1 in the form of x over itself. So we have, in following through, Okay, so you have 5 times 2y becomes 10y. Okay, we have all over 4x squared y squared. And then we have plus 3x, which will be also over 4x squared y squared. And you could have gone ahead and combined the numerators or the outputs. You can express, you can say either as 10y plus 3x, all over 4x squared y squared, or as 3x plus 10y if you put the numerator terms in alphabetical order. Also over 4x squared y squared. And I'll tell you what, just for the next few minutes, in terms of looking at rational expressions and operations, let's try the following. Okay, say we have 3/10 minus 2/5 and also where we have 5 over, so you have 5 over 2xy squared plus 7 all over x squared y. Okay, so for the next few moments, let's see what we get for the difference in number 1 and for the sum in number 2. Okay, so if we look into these items, okay, we have, first of all, we have 3/10 minus 2/5, okay, and so for this particular difference, okay, now the least common denominator is 10, which will be present in the first ratio. Okay, so we have here, we have 3/10 minus, and for 2/5, going from fifths to tenths. So we'll multiply 2/5 by 1 in fractional form, and that fraction will be the number of times that 5 goes into 10 divided by itself. So again, we're going to have 2 halves. So we have 3/10 minus, and then we've got 4/10. So for 3/10 minus 2/5, again, this translates out to 3/10 minus 4/10, so this will become negative 1/10. Okay, now for the sum of the next set of fractions, okay, to be able to add together, okay, we need a common denominator. And for the least common denominator, okay, so we have we got 2, and for x and x squared, okay, so we have x to the second, and in y we have y to the second. And in looking at what we have here, so for 2xy squared, if I raise this fraction in terms of the least common denominator, okay, so we already have 2 in the first ratio denominator. Now for x into x squared, okay, this will go x times, and we already have y squared present. So I only had to multiply the first ratio by 1 in the form of x over itself. As for 7 over x squared y, Okay, so we got 2, and x squared into itself is 1 time, and we have a factor in y left over. As I take y into y squared. And just going ahead and consolidating. So both of these denominators will be at 2x squared y squared. And as for the numerators, we got 5 times x is 5x. And you got plus 7 times 2y. And that's going to be at 14y. And I just went ahead and consolidated. So we have for the result, okay, we have 5x plus 14y all over 2x squared y squared. All right. Now, as a remaining case, and this is going to go back to stuff that you might have encountered in the past, like with factoring and prime factorization. And let's say if you have a trio of fractions. See, we have 3 over 8x cubed y squared. We have plus 1 over 24xy. And we'll say have plus 2 over 27 x to the 4th, y to the 3rd. Okay. Now, if I'm looking for the least common denominator, okay, we have along with the variables, okay, I'm looking at the smallest number that all of 8, 24, and 27 will go into. And just looking at it in granular terms. Okay, so you have with the number 8, if I take what's referred to as the prime factorization, and what I mean by this is I'm going to factor this into prime numbers, and prime numbers are going to be those positive counting numbers whose only factors will be 1 and that number itself. So we have in the case of 8, say if I factor, okay, have like 8 is going to be 4 times 2. Now 2 is a prime number, since the only counting numbers that are factors of 2 will be 2 and 1, or 1 and 2. Now with 4 factors out to 4 and 1, and 2 and 2. Okay, so 4 can be factored further to 2 times 2. And guess what? So for 8, you have the prime factorization is going to be 2 times 2 times 2, or 2 to the 3rd power. And say for 24, okay, say have like with 24, a factorization to begin with is going to be, one possibility is going to be 6 and 4. And again, 6 and 4 are composite numbers, meaning that you have like, other than 6 times 1, you also have 3 times 2. So from 6, we say you have 3 times 2. And with 4, once again, we have 2 times 2. And 3 and 2 are both prime numbers. Now as for 27, we say that 27 is 9 times 3. Okay, now 3 is a prime number. However, with 9, you have 9 times 1 and 3 times 3. So I can break down the 9. That's 3 times 3. Then you have followed by 3. So for what we have in the big picture, okay, we have the prime factors of 8, 24, and 27 that were drawn out. Okay, we have with 2 and 3. And we have with the variable factors, okay, we have those to be in the letters x and y. and just taking what we have for the least common denominator. Okay. Now you got your prime factors at 2 and 3. So what we want to do here is that from what we have among these three factorizations, I want to draw out the greatest representations of 2 and 3 in terms of how much they are drawn out. Now with the number 2, it's not drawn out at all from 27. It's drawn out 3 times from 24, and likewise with the number 8. Okay, so the most that 2 is drawn out or factored out, or the number of appearances from any of the factorizations, you had to appear 3 times. And with the number 3, it doesn't appear at all from 8. It appears only 1 time from 24, and we had to appear, so the winner comes from 27. So the greatest number of appearances of 3 from any of the factorizations is going to be 3 times, that coming from 27. And as for the variable factors, you're looking at the highest degree representation of x and y. So out of this trio, for x, we have x to the 4th. And for y, the highest degree is going to be y to the 3rd. So we have for the least common denominator, okay, you got 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, and 8 times 27, that's going to be a 216. And again, we have in the variables, we have x to the 4th and y to the 3rd. So just taking what we have in the numbers and variables, okay, so each of these fractions will be raised. Okay, so we have for the first of the ratios, we have 3 over 8x cubed, y to the 2nd. And in terms of making the adjustments with the first ratio, now 8 will go into 2/16. So if I were to divide 2/16 by 8, that's going to be at 27. As for the variables, if I take x cubed into x to the 4th, I still have a degree in x remaining. And if I take y squared into y cubed, I still have a degree in y left over. So I'm multiplying the first ratio by 1 in the form of 27xy over itself. Again, 8 into 2/16 is 27, and x cubed into x to the 4th is x, y squared into y cubed is y. And as for the second ratio, for 1 over 24xy, okay, so 24 into 2/16, or 2/16 divided by 24, that's going to be 9. And then we have x into x to the 4th, leaves us with 3 degrees in x. So we have x cubed, and y into y to the 3rd. That is going to be y to the 2nd. That's for 2 over 27. X to the 4th, y to the 3rd. Okay. And what's going to happen here, if I take 27 into 2/16, that will go 8 times. And if you notice, we have x to the 4th already present. X to the 4th into itself is once. Y cubed into itself is once. So the last ratio had to be multiplied by 1 only with 8 over itself. And so we have for this final result, okay, we have all denominators. Okay, we have it, the consolidated term, 216x to the 4th, y to the third. And as for the numerators, okay, got 3 times 27xy. So I have 81xy plus 9x cubed y squared. And finally I have plus 16. And that will be the final result in this case.